Welcome back to ZOS Introduction. This is the 25th video in the series. The learning objective is to list major components of communications server, describe the IBM Z Open Systems Adapter, also known as OSA, acquire an awareness of hypersockets, vSwitch, and the rich set of network security features available with Communications Server. To acquire network certification credentials, detailed knowledge of network layer model is mandatory. The awareness of the three network layer models are important when supporting large enterprise mainframe environments. The introduction of the IBM mainframe in the mid-1960s started a business renaissance, which started a race to gain competitive advantage, productivity efficiencies, and last but not least, grow a successful enterprise to be nationwide and even worldwide. The race for competitive advantage, productivity efficiencies, and nationwide growth required data communications networking, which is fully matured today, but that was not always the case. In the early 1970s, the network consisted of analog telephone lines designed for voice. Passing data using the 1970s analog network infrastructure required invention of a data network architecture to overcome issues with speed and accuracy associated with using analog circuits designed for voice traffic. IBM invented and delivered SNA, or System Network Architecture, in 1974 for centralized IBM mainframes to have a wide area data network reach with reasonable speed and accuracy. The SNA design and implementation is represented in the 7-layer model on the right side. TCP/IP was under development and dealing with the same speed and accuracy problems of using the 1970s analog network. TCP/IP became available on January 1st, 1983, with activation of new protocols. TCP/IP design and implementation is the 5-layer model on the left side. The middle 7-layer model, labeled OSI, is the Open Systems Interconnection Model, published by the International Standards Organization in 1984. So what existed for networking in the mid-1980s was SNA and TCP/IP. Companies needed to make a choice between SNA or TCP/IP for data traffic. SNA was extremely good with excellent network management. Many companies implemented pure SNA networks to acquire early competitive advance, productivity efficiencies with reasonable speed and accuracy required for passing critical business data. The worldwide physical network infrastructure began to change with implementation of digital circuits that was great for both voice and data. The combination of a digital circuit infrastructure using TCP/IP was a big win because it was significantly less costly than a pure and dedicated SNA implementation. SNA remains a superior architecture and is still used today. IBM made the choice between SNA or TCP/IP relatively easy for businesses. IBM combined the SNA and TCP/IP layer stacks and called it Communications Server. SNA sessions still exist today. All TN3270 sessions are SNA sessions. Many large enterprise point-of-sale devices communicating with a centralized mainframe or SNA sessions. Many SNA sessions exist between large companies. An example is when you shop at a large retail department store and at the point of sale, you request and receive a store credit card from the retailer. The point of sale is used to issue the store credit card. This is made possible because in those few seconds, the store's retailer software initiated a mainframe-to-mainframe communication with a credit card bureau to validate you and your credit score. VTAM, shown in the diagram, is the address space for managing SNA session traffic. IBM developed a mainframe network adapter called Open System Adapter for handling network traffic. So now the vast majority of the physical network communication equipment and circuits are IP, and the SNA protocol involved with end-to-end SNA sessions is simply packaged up inside of an IP packet. Communications server tightly couples the VTAM and TCP/IP protocol stacks to optimize the network communication using I/O buffer areas managed by Common Storage Management. The Open Systems Adapter, commonly referred to as OSA, is actually a network controller that you can install in a mainframe I/O cage. The adapter integrates several hardware features and supports many networking transport protocols. The OSA card is the strategic communications device for the mainframe architecture. The IBM Red Book shown has details about the variety of OSAs and OSA configurations available. While on discussing communications server, keep in mind that a single IBM Z may be concurrently running hundreds and even thousands of operating systems, and there exists IBM Z technology that enables these operating systems to communicate with each other without ever leaving the IBM Z mainframe. The technology is HyperSockets and vSwitch. The technology enables near zero network delay between the operating systems and eliminates need for extra cables and so on. Communications server is rich with security monitoring, and traffic privacy features. A new feature with the IBM Z14 of z/OS version 2 release 3 is z/OS Encryption Readiness Technology, or ZERT. ZERT is more than the name implies. ZERT is capable of immediate reports about the various z/OS session traffic to ensure strong encryption is enabled. If a weak encryption is enabled, ZERT will report the encryption is inadequate. As previously mentioned, the communications server is rich with security monitoring, and traffic privacy features. Observe the integration with SAF, or System Authorization Facility, enabling a z/OS security manager such as RACF to define network subject and object resources to provide very granular security authorization, as well as security certificate management and processing. To advance your knowledge and skill level, review the IBM Red Book Z Connectivity Handbook, which is 32 manuals dedicated to Communications Server and z/OS Internet Library Communications Server bookshelf. Many excellent sources of information exist for Communications Server, such as the URLs on the chart. In summary, Communications Server is the z/OS communications gateway to the Internet or company intranet. The presentation explained the major components of Communications Server, which are TCP/IP, VTAM, and Common Storage Manager. The presentation made you aware of the Open Systems Adapter, HyperSockets, vSwitch, and the rich set of communications server network security features. Thank you for your time.